Hey, let's take a look at your MT3LT5 affirmation. And here we have a square. And we're supposed to know which one of these are going to be lines of symmetry or points of symmetry. First one, let's talk about rotations. Since it's a square, it's an equilateral polygon. It's a regular polygon. So I can rotate this 4 times because there's 4 points, 4 vertices, 4 sides. So if I take 360 and I divide that by 4, every 90 degrees is going to be a rotation that's going to turn it onto itself. So every multiple of 90, so 90, 180, whoops, forgot my 0 there, 270, and always 360, because we know 360 always turns everything onto itself. So now let's take a look at it. So if we do a rotation through the center of 270 degrees, that will rotate it onto itself. 180, yes, that'll rotate it onto itself. How about, can we reflect it across line N? That is every point have its matching point straight across line N? Yes, it does. How about across the diagonal M? Well, notice, once again, every point is equidistant from the diagonal going at a 90-degree angle. So this one is also, so in other words, on this question, you should have selected all of them. Let's take a look at another shape. Here's a rectangle. Now, notice, rectangle is not regular. It's not always the same. How about 180-degree rotation? If we flip it 180 degrees, while rectangle is opposite sides the same, so yes, that one would work. How about if we reflect it across line B? Well, line B is this horizontal line. Oh, yes, and every point has its matching point across that line, so we would do that one. How about across the diagonal? Here's the key. Notice in this diagonal, it's not equidistant, is it? In fact, here's a picture of what it looks like when I do the reflection. So it does not reflect onto itself across the diagonal. 90 degrees. Since it's not regular, if you turn it 1/4 of a turn, the rectangle will be pointing up, and that is not matching onto itself. So the only one you should have clicked on, those two were the first two. Let's take a look at this hexagon. If I reflect it across point G, how about line G? Sorry about that. And once again, every point is horizontally the same distance from that point, so that one we will. How about a rotation? Well, there are 6 points on this hexagon, so I'm going to take 360 and we divide it by 6, which is 60 degrees. So every multiple of 60 is going to be a rotation that would rotate onto itself. So 60, 120, 180, 240, 300, and 360 degrees. Those will work. 288 is not a multiple of 60 though, is it? So do not select that one. How about 144? That's not a multiple of 60. How about across line H? Well, kind of like the rectangle, not every point is the same distance across this diagonal. So this is not a line of symmetry. So the only one you should have selected on this picture was line G. Let's take a look at a triangle here. Triangle, now this is an equilateral triangle because they told you that in the directions. So we'll kind of do the same thing we did on the others to figure out if my rotation's through the center. So I take 360 divided by 3 because there are 3 points. So I get 120 degrees. So a rotation of 120, 240, and 360 would plot the triangle onto itself. 144 is not a multiple of 120, so not that one. How about line B? Well, every point is vertically opposite that point, isn't it? No matter where I pick. So definitely across the reflection across line B. How about across line A? Well, we can see if I take the vertex right here and I flip it, I don't have a point here, I got a side. So definitely not line A. 120. Oh, that one is a rotation through our order. So it should have selected both of those. So at this point, I'd like you to go back and redo this affirmation and send me an email when you're done.